Well, it looks like this video that I did on configuring a home lab in 90 minutes using the vManage 20.15.1 software is going to turn into an entire series. To say that this video has been well received would be an understatement from the perspective of how my channel normally performs. So I have been receiving numerous requests from people via direct messaging, via LinkedIn, with regard to additional steps that might be taken that they would like to see entertained. So what I'm going to do is I'm going to jump over to my resource here, my jump box. And what I've done is I have compiled a list of all of the tasks that students have been asking to see. Now, this is going to refer to not just CCIE students. This is going to refer to pretty much anyone that has been consuming my content. And you can see here, I've created a basic set of 6 individual tasks. Now, what I thought would be fun is that between now and the end of the year, if I could do a single video on each of the individual tasks in this list, as well as address any of the questions and any of the configurational requests coming from people watching these videos on YouTube, I thought it would be pretty cool, and it would also allow me to be able to engage more. So the idea here is that this is going to end up turning into an SD-WAN series of videos for basic functionality. And in this, I plan on looking at each of these individual tasks and any future tasks that might be submitted from anyone watching the video. So right now, if you have any interest in seeing anything done specifically in this lab environment, to include expanding this lab environment, what I would like to do is I'd like you to provide that question in the comments. And if it aligns with the direction that I want to take the videos, obviously I'll add your suggestion to this overall list of tasks. So the hope here is that we're going to create an ad hoc lab series that's going to talk about implementing specific things inside of SD-WAN. I don't care what those include. If you want to look at security concepts like Umbrella, we have that capability here. If you want to look at anything from templates to configuration groups, add it to the list and make a comment in the comments below. Additionally, I would greatly appreciate it if you guys would go ahead and subscribe and like the videos, anything to help me do battle with the YouTube algorithm. So I'm going to go ahead and stop right now. And what we're going to do is we're going to turn our attention to task 1 in this list. And specifically, that means that we're going to be adding the MPLS router as a transport option for the 2 cEdges that we have in this environment. And we're going to do that starting right now. So taking a look at our tasks, let's just do a brief overview of where I'm currently going to drive the bus. Unless suggestions change the order of operations, this is going to be what I intend to do. Task 1 is going to be to create the configuration necessary to configure the MPLS transport. Now, initially, we're going to go ahead and use a static route to do this, but task 2 is going to ask us to engage BGP transport side between cEdge 1, cEdge 11, and the MPLS router. Now, what that means is we're going to have to run BGP. We're going to have to define some autonomous system numbers and all of those things. So right now, rather than go ahead and talk about everything that I'm going to do, because this list may change based on the viewer input, and again, provide your comments in below with regard to the description or the chat with regard to what you would like to see implemented moving forward, because again, your suggestion may change the nature of this ad hoc video series. So what I want to do right now, first of all, is just turn our attention to task 1, because that's going to end up engaging the vManage in some ways that many people may not be familiar with. So what I've done is I brought up a notepad that is actually going to outline the tasks that I want to implement in order to be able to complete task 1. Task 1 being creating the necessary configuration to connect to the MPLS transport. Now, my first problem is the MPLS transport router is blank. So what we're going to want to do first is we're going to want to configure the MPLS router with IP addresses. Now, I'm going to modify my topology drawing as we go through these series, and then ultimately I should be able to export this as a UNL file in its final format at the end if somebody wants to be able to go through this from scratch. But right now, the process is going to end up being following along with what I'm doing. So the MPLS router, as I said, should have no configuration on it if I remember correctly. And that is going to end up being indeed the case. So what I want to do right now is I'm going to go ahead and say, no, I don't want to engage in the auto config or the initial configuration dialog. So I'm going to let that kind of run right now. And what I want to do is I'm going to go ahead and quantify the networks that I'm going to be using. So for the MPLS, I'm going to use 40.1.1 as my address range. Again, we're going to stick with .30s. So in this case, it's going to try to match what we currently have on the other device. So this is going to be 40.1.1. In this case, it's going to be 12/30. And again, the first issuable IP address will be on the router. And then what I'm going to do is I'm going to go down here and I'm going to go ahead and edit my style and do the same thing. It's going to be 40.1.1. And in this case, it's going to be 16/30. And those are going to end up being the networks I'm going to use. I'm going to apply the IP address that's going to be the first issuable on the MPLS. So this is going to be .13 for gigabit 4, and it's going to be .17 for gigabit 5. And we'll use those as the gateways of last resort in the rest of the lab. So let's go ahead and see if I can't get this thing to work and play well. So Control-C. For some reason, this router seems to be wanting to run pretty stinking slow. So we want it to, I may end up stopping it and restarting it. So this device is actually, if I take a look at the way I've got it configured right now, let me just right click on it and go to details. I think it's a CSR. It is, I'm not happy with this specification. So as you'll see, if I right click on the internet router and we go to the details, I actually changed the specifications to a CPU of 4 and a RAM of 1638. That's my problem. So what I'm going to do is I'm going to go ahead and I'm going to stop this node and we're going to change it. So again, 32,768 is going to end up being my RAM. I'm going to edit this. And we're going to change the CPUs to 4. We'll change it to 32,768. We'll go ahead and hit save. And then I'll restart the device. Don't worry, I won't drag you guys through all of this. I'll just edit this out once the video's done. I guess this is one of the drawbacks of doing this quote-unquote live. So I need to exit out and let's go ahead and reopen our session. And again, I'm using I'm using Secure CRT in my environment. You may use something different, but I'm just trying to make everything look as nice as possible as a direct result of being able to use the color coding inside of Secure CRT. So let's wait for this to boot up and then I'll make my changes. In fact, what I'll probably do is drag this over just a little bit so that I can see the interfaces and the networks that I am going to apply. All right, so it's going to go through the auto install. Wait for that to fail out. And now we should be good to go. And the device should be a little bit peppier. So I'm going to go ahead and say, no, I don't want to enter the configuration dialog. Yes, I want to auto terminate the auto install. And then we should be able to get the baseline configuration set up on the MPLS transport router. Now, specifically, while this is coming up, I want you to note that the MPLS router has 0 connectivity to the internet router. This would be a perfect example of a public transport versus a private transport. And I'm doing this intentionally. Now, ordinarily, I would have a link between internet and the MPLS for circumstances where I might want to bring up a device that is only going to be connected to MPLS. And the problem is MPLS offers no reachability towards the controller. So that can cause some design issues. And we are going to want to talk about that. But, obviously, we're just basically trying to go through these allotted tasks. So I'm waiting to get into the router. So let's go ahead and say enable. We'll say config terminal. I'm going to go to interface gigabit 4, and I'm going to do IP address. We said we'd use 40.1.1.13/255.255.252 for a /30. I'm going to no shut that interface. And then I'm going to go to gigabit Ethernet 5, and I'm going to put in the IP address for it, which will end up being 40.1.1. This is going to end up being 17.255.255.255.252. And I'm going to do my no shut. End. Actually, let's do exit. We'll change the host name to make it make sense. We'll just say MPLS. I'll do an end, and I'll do a write on this guy because I don't want to lose that config. Let's take a look at the interfaces. We'll do show IP. Interface brief, exclude assigned addresses. And we've got 40.1.1.13. We've got 40.1.1.17. So we've got all of the gateways of last resorts configured on the device. And as a direct result of this, we should now be able to bring up the interfaces on cEdge1 and cEdge11. Now, let's take a look at the steps that I outlined. So the first thing that what I want to do is I want to detach all devices from the current feature template. Now, here's why. As long as I have cEdge1 attached to that device template, anytime I make changes to the device template or to feature templates that are referenced inside of the device template, the vManage is going to want to go ahead and propagate my change the very instant that I update either of those two configurational tools. Now, I want to mitigate that, so I want to make all of my changes, and then what I'm going to do is I'm actually going to apply the configuration template to both devices. So that's going to be cEdge1 that we brought up manually and cEdge11, which we did the bootstrap configuration for. So let's see what that looks like from the perspective of the environment. So let's go ahead and navigate over to the vManage. I'm going to have to log into it. All right. So again, I don't want to participate in a smart account. That's part of the exercise here. I also forgot to fix the Neo4j database. But right now, like I said, we're going to navigate to configuration. We're going to go down to the classic view. We're going to go to templates. I want to go to device templates, and we can see here that I have cEdge. By clicking on the device attached, we can see that I have cEdge11 attached to that template. I am going to go to the three dots, and I'm going to say I want to detach all devices. Now, this does not remove the running configuration. That's one of the first things that a lot of people are confused by. So if I have a template attached to a device and I detach that device from that template, the device keeps its configuration. Now, if I modify the template and then reattach it, whatever modifications I made will be added to, or if I remove something as part of the modification of the device template, then obviously that configuration will be removed. So absence of config is tantamount to telling the vManage that by not applying it, you want it to remove it if it is there when you attach the device back to the template. So the object of this exercise is to get this guy detached. And once it is detached, what we're going to do is we're going to make our changes. And then once our changes are made, we're actually going to propagate those changes by reattaching cEdge11 and adding cEdge1 to that list. So let's go ahead and take a look at the next step. So we've done the detach. So if I were to go ahead and say this one right here is done. So let's see, can I do I was hoping I could do a strike through or something to the text, and right now I can't. So let's take a look at this. This is Markdown. So it's all based on the values for, well, like I said, I was hoping I would be able to do some kind of mark through. I did not mean to take it all the way back to where I had it. So what I've done is I've lost all of the quote unquote formatting now. So I've got Markdown, and then when I go back, it's just becoming more and more problematic for me. I'm probably going to install an application or something like Notepad++, which will give me a little bit better options here. So, can I clear formatting? I need to highlight the text. Edit. Yeah, I just made a big mess. That was not what I wanted to do. So let me do some house cleaning here. All right. So we had step 1, which was to give the IP addresses to the MPLS. We've done. Step 2 was to attach the current template. So right now we're on step 3, which is going to end up being to create the new device templates, actually to create the new feature templates that we're going to need. So create a new interface feature template to be applied to current and future devices. Now, what I'm making reference to here is going to end up being Gigabit Ethernet 2. So if we take a look at our configuration and I go down to templates and I go to feature templates, what we'll see here is I should already have a custom interface template right here for Gigabit Ethernet 1. Now, what I'm going to do, rather than recreate everything from scratch, I'm going to copy this. And what I'm going to do is I'm going to call this VPN Gigabit Ethernet 2 interface template. And when it gets implemented, the changes made, then what I'm going to do is I'm going to find it and I'm going to edit it. I want to make the changes so that this feature template is different than the one that I copied. That means I'm going to need to change my variables to make sense. It means I'm also going to need to modify the tunnel configs. So right now this is for Gigabit Ethernet 2. So the interface is going to be globally Gigabit Ethernet 2. No shut is good. The IP address it's going to ask me for is going to be Gigabit Ethernet 1. So I'm going to go ahead and edit that to say Gigabit Ethernet 2. We'll scroll down. Tunneling needs to be on, but this is going to end up being a different color. It's going to end up being MPLS. I'm not going to worry about restrict. Allow services, all is what we want to have configured. No QoS. No special configs. Let's go ahead and update the configuration. So now I have a second interface template that's going to be in play for VPN 0, covering the configuration necessary to bring up Gigabit Ethernet 2. Now, the next thing in the task, let's go and we'll go ahead and just clean this up as I go, is I need to make a modification to the VPN 0 feature template. Because right now I'm not running a routing protocol with the MPLS router. I'm going to need to have a second default route. I want a default route pointing out towards the public internet, and I'm going to want a default route pointing to MPLS, wherever this template is going to end up being employed. But right now, I only have the capability of being able to define one gateway of last resort in VPN 0, and to modify that, I need to modify the VPN 0 template. So let's go ahead and make that change. So now, again, I'm going to go to configuration, down to templates. I'm going to go to feature templates. I'm going to find VPN 0, the VPN 0 VPN template. I'm going to edit it. I'm going to navigate down to the IPv4 routes. So IPv4 route. Wait for the screen to resolve. I gave the vManage 16 CPUs and 32 gigs of RAM, and it's still kind of slow. So what I want to do now is I want to add a second next hop. So to do that, I'm going to go to Edit. Try to go to Edit. I'm going to go add a next hop. I'm going to add a new one. Right. I'm going to add a new, it won't let me. I may end up having to change browsers. So add a new next hop. Trying to figure out if there's a problem with my keyboard. So add a next hop. Yeah, I've run into, like I said, I've encountered problems like this. So what I'm going to do is I'm going to cancel. Trying to figure out if I have multiples of these open. But yeah, so right now I got a problem, and the problem is, let's see if I can resolve this by refreshing. Worst case scenario, I'll go to it in Firefox. But again, these are the kind of issues that I've run into in production environments with different browsers having different issues. So let's go ahead and just clean these messages up so we won't have to look at those. A lot of it also happens because I get impatient. Let's go ahead and click on Edit, and I'll wait this time instead of clicking it 10 times. Okay. Still not giving me a screen. There's the pop-up. Next hop. Yeah, I'm going to try it. If it errors out again, okay, I'm good. All right. So like I said, sometimes you just have to be, for lack of a better word, patient. This is going to be Gigabit Ethernet 2 dash next hop dash IP. And we're going to go ahead and save those changes. And now I should save one more time. And what we should see now is I have 2 gateways of last resort in the mix. Now I'm going to go ahead and select Update, and this should apply. So the next part of this is going to end up being that I need now to use these new feature templates inside of my existing device template. If you think of like feature templates being the building blocks that represent my configurational intent or your configurational intent, we then use those building blocks to create our desired outcome. And that desired outcome is going to end up being an object that we call our device template. Now, keep in mind, in my lab right now, everything is 100% uniform. We're trying to accomplish the same things everywhere in our environment on all of our devices in the same way. The Gigabit Ethernet 1 points to our public internet. Our Gigabit Ethernet 2 points to MPLS. When the time comes, we'll probably have uniform service-side facing interfaces. So it's really easy to have one device template that I can use ubiquitously everywhere in my environment as long as my environment aligns that way. In production environments, you may end up having device templates for dual or 3 times attached environments, what we refer to as dual or multiple uplinks. We might have single uplink feature templates or device templates, excuse me. So the object of the exercise is to understand that through the creation of feature templates, I can utilize those devices to be able to create unique device templates that might have different assemblages of individual feature templates. Now, the more unique a site is, the more unique a device is within a site, I may end up having to have a unique or an individual feature template just for that specific device. So this is one of the drawbacks to template architecture, and one of the reasons that Cisco has tried to move over towards the concept of configuration groups, because they're, in my perspective, easier to work with, more visible, and they're also semi-containerized. So for every feature template I create inside of the feature template window on the SD-WAN environment, the name has to be unique for every unique feature template. And you can see how the more differences that we have in our environment, the more uniqueness there is to our individual resources and our WAN edge devices, the more of these feature templates I'm probably going to end up needing. And this leads to something called template sprawl. But right now, the task is pretty straightforward. Let's go ahead and take a look at the next step. The next step says we want to modify the existing device template in such a way that we can use these new resources. Now, the reason that we detached the template in the first step, or in the second step, excuse me, was so that when we made a modification to the VPN 0 template, the system did not dynamically try to propagate that change, absent the application of the new interface feature template that we created. So in this regard, what we can do now is we can modify the template, save it, update the template, and then what we can do is we can just selectively attach both resources, cEdge1 and cEdge11, to that template to get our desired result. So let's look at the device template, of which I only have one right now because everything's created equal in my environment. I'm going to go to the three dots, I'm going to edit it, and I'm going to make a change. Now, the change that I'm going to make does not require me to modify the VPN 0 template because it's currently using the feature VPN 0 template or feature-based feature template that I created called VPN 0. So the VPN 0 template is in use. The VPN 0 Gigabit Ethernet 1 template didn't change, and I still intend to use it. All I really need to do is add the VPN interface Ethernet template that's going to represent Gigabit Ethernet 2, and for the most part, I'm done. So now when I hit update, it's going to update the template, but it's not going to force me to wait for the vManage to update the devices because there are no devices attached to it. That's going to bring us to the very, very last step. The last step is going to be to go ahead and reattach Ethernet 11 or reattach cEdge 11. And then also we're going to go so far as to add cEdge1 at the same time. We'll provide any of the missing variable information, and we should be able to bring the devices up. So let's go ahead and take a look at that. So from the perspective of the last step, step 6, what we're going to do is attach both devices to this device template and provide the information for the variables. All right, so let's look at it. So we're going to navigate over to all cEdges. I'm going to now attach devices. The two devices that I'm going to attach are the two cEdges that we have in the lab. We'll drag that over to the selected devices. We're going to hit attach, and the system is going to solicit the values for the corresponding variables. The easiest one to fix here is going to end up being the cEdge 11 because the system remembers the configurations that we have. We're going to go ahead and say that it's going to be 40.1.1.17 because we kept the same subnet configuration, and Gigabit Ethernet 2 is going to have the address of 40.1.1.18/30. And I'm going to go ahead and update. Now, the next part of this is going to be I need to provide all of the information for cEdge1 because this cEdge has never been associated to this template. Now, that means everything needs to be provided. So my site ID is going to be 100. My system IP address is going to be 1.1.100.1. We're going to go ahead and say cEdge1 is my host name, and I need to get my IP addressing and my 2 gateways of last resort. So real quick, I'm going to jump over to the infrastructure, and it's going to be 39.111.12, so my gateway will be 13. So for the first one, it's going to be 39.1.1.13. It's going to be 40.1.1.13. Gigabit Ethernet 4, I'm sorry, Gigabit Ethernet 2 is going to have the address of 1.40.1.1.14/30, and it'll be 39.1.1.14/30 for Gigabit Ethernet 1. Now, if you've made a mistake and your variable name doesn't make sense or something, you can actually take your mouse and put it on top of the line item, and it'll tell you what it is you're issuing here. So we're assigning an IP address in VPN 0. You see the /0 for Gigabit Ethernet 1 interface IP address. It's telling me what it's asking for. But we normally try to create as unique and as accurate and human readable variable definitions as possible. And that means that we should be able to recognize everything in our environment. So our next step is going to end up being to hit next. And then what we're going to do is we're going to configure the devices, which is going to notify the vManage that it needs to use the DTLS tunnels that are running netconf configuration or netconf protocol to apply configuration to our devices. Those devices will then come up and be operational. Now, if there is a issue, so if I do, let's say I messed up my 2 static default routes and I lose the ability to be able to communicate to the device is going to wait for 5 minutes. If it loses the ability to communicate to the vManage or the controllers as a result of applying a template, and what it's going to do is it's going to roll back to its last known config. And the assumption is that since that was operational before the change, that's a safe rollback position. You will end up having to wait the amount of time for the vManage and the device to realize they're no longer communicating. And once it makes that realization, in 5 minutes, it will roll back to its last known config, and then you can make modifications and changes and try to fix what you did wrong. So from the perspective of the implementation, I'm going to go ahead and say next. Now, what I want to do is there is an option here that says configure device. I'm going to click on the configuration device. This is going to be the configure device rollback timer. And like I said, it looks weird because it's 6 and 15 and it's smack dab in the middle, but the default time is 5 minutes. This rollback is enabled. It's a safety net to protect us from mistakes. We could exempt devices from it. I would not recommend doing that unless you're instructed specifically to do so, and you are given concrete reason. But right now, all I'm going to do is I want to hit cancel, and I'm going to go ahead and say I want to configure these devices. Now, taking a look at, say, cEdges1, I can click on it, and I can do what is referred to as a config diff. And the config differential can be configured such that I can see the modifications and changes that are going to be made to the device as a result of applying the configuration. It's going to give me the ability to be able to look at a configuration differential, and I can do it side by side. And what you can see here is anything that's red is being removed, anything that is green is being added, and anything that is going to end up being amber is going to end up being modified. And again, this is based on the application of our template. Now, you'll notice that some things in our template are going to happen, even though we haven't defined them. I didn't tell it to remove Gigabit Ethernet 3 and Gigabit Ethernet 4 directly, but by not configuring something inside of the device template representing Gigabit Ethernet 3 and Gigabit Ethernet 4, I'm implying that I do not want them to have config. So you can see here all of their configuration is being quote-unquote removed. Lots of configurations and modifications are being added. Let's go ahead and configure these devices. I'm going to confirm the fact that I want to apply the configuration to 2 of my individual routers, cEdges1 and cEdges11, and then all we need to do is wait just to make sure that everything happens the way we expect. So we want to see this be successfully applied to both of these devices, and as a net result of this, we should ultimately end up with 2 IPsec tunnels, one through public internet, and then the other through MPLS. So let's monitor what's happening by taking a look at the actions. I'll speed this up in post-production. All right, the application has happened successfully in both instances. Let's take a look at the devices in question. So I'm going to navigate to cEdges1. From cEdges1's perspective, I want to log in admin 1234 QWER. Let's take a look at show IP interface brief, exclude assign addresses. We now have gigabit Ethernet 2. If I take a look at show SD-WAN, running configuration for SD-WAN, it should give me my output that's going to show me I have gigabit Ethernet 1 configured as part of public internet, which is carryover from the last video. We have gigabit Ethernet 2, which is operating as a color of MPLS. And as a direct result of this, I should see 2 tunnels when I type show SD-WAN BFD sessions and hit enter. I have the configuration, and what we note right now is we have a scenario that we need to address. And the scenario that we're going to have to address here is the fact that right now I'm not seeing a second tunnel. Now let's take a look at the show IP route and look at the routing table. Now I have a static route going out of 40.1.1/13, and I've got 39.1.1/13 configured. Let's take a look at cEdge 11, make sure I didn't fat finger something. So we'll do admin 1, 2, 3, 4, QWR, EN, show IP route. Should have 2 static default routes, which I do, both obviously being reachable. If I take a look at, say, ping, I want to ping 40.1.1. I'm on 11. Let's see, can I ping the IP address on cEdge 1? So I'm going to ping 14. So can I ping 14? So right now I have no IP reachability to 40.1.1.14. Now I have a default route. Can I ping 39. Can I ping 40.1.1, and my gateway of last resort should be 17. Can I hit my gateway of last resort? I can. Can I hit 40. Let's see, we were trying to ping 17, so looking at the addressing schema. So we're here. I can ping this address. Can I ping 13? So 40.1.1.13, that's the IP address assigned to the MPLS router. So I'm going to go ahead and say 13. So at this particular juncture, I can't hit that address of 40.1.1.13 as far as resolvability. So let's go up to MPLS. And again, troubleshooting is all part of this process. So if I say EN and I say show IP interface brief, E assigned addresses, from this case, can I ping 40.1.1.7? Let's see, we want to see 18. Can I ping 14? So the next higher address. So I've got the reachability in place here, but that begs the question, am I using the right IP addresses? So am I using 18 on cEdge 11? So show IP interface brief, E assign address. And sure enough, I am using 18. Does it have the right mask? Show run interface gigabit Ethernet 2. So 40.1.1, it's got the right route to it as far as the configuration goes. So I can actually hit both of those addresses from here. So what do I need to do? Well, let's try this. Let's say config T. We're going to say router OSPF1, and I'll say router ID 000002. Sorry, 1. Oh, this will be the second router, so we'll do 2. Let's see, can I run network 40.0.0.0.0.255.255.255 area 0? Will that run a routing process for me? Show IP route. Now, do I need a routing protocol? Well, I mean, I don't have a routing protocol on business public internet, but again, these are all questions that I keep getting asked. So I decided that we'd take this as an opportunity to explore things. So if I say show IP OSPF interface brief, Okay, both interfaces are running in OSPF. Will that make a change? Let's go down to cEdge 11 and let's take a look. So if I say ping 40.1.1.13, so that's a no-go. All right, so again, from MPLS, I can hit all of the addresses. So show IP interface brief, the assigned addresses, show run interface gigabit Ethernet 4 should be a 255. Gigabit Ethernet 5 should be a 255. So we've got 17 and 13. Let's take a look at cEdge 1. From cEdge 1's perspective, show IP interface brief, E assigned addresses. So using the same addressing schema. So we did show run interface gigabit Ethernet 2. Those are all the correct addresses. So show IP route. I have both of the static default routes configured in here. So again, ping 39.1.1.14 should have reachability. Ping 40.1.1.14, so the other end got reachability. Check it from cEdge 11's perspective one last time. Show, well, we'll say ping 39.1.1. In this case, it's going to be 17, should have reachability. Ping 40.1.1. And we'll go ahead and ping 17. That's our gateway. So taking a look at what's happening, show IP route. I have my static default route. I'm not learning any routes because I'm not running anything service side. So we need to take a beat here and see if we can't figure out what's happening inside of our environment from the perspective of troubleshooting. So every lab I ever try to do is all about the concept of troubleshooting. Now, the scenario and the situation that we need to look at here is going to end up being related to our config and our topology. So after some consideration, I am going to need or want to take a look at some of the messaging. Notice right here, we have values here that's saying control dash connection, TLOC IP, and we've got some additional values that I can't see. Can we do show log on this device? So show logging. And let's see if we can see any of these messages that are coming through. So we've got geofence messages. We've got our turn up, the formation of our peers. And we have some basic messages here with control connections. So let's take a look at the control connection. So what I'm going to do right now is I'm going to go ahead and say show SD-WAN control connections, plural. All right, so from the perspective of this resource, we can see that we've communicated to the vBond twice. It doesn't really matter as long as we're getting to it. But again, the vBond is only reachable through 39.1.1.2 as far as the path that I can get to it. Because remember, again, MPLS is not connected to business or public internet. I keep wanting to say business internet. I apologize for that. So let's go ahead and take a look at the results of show SD-WAN OMP peers. Do I have a appearing to the vBond? Sure, I do. Now, what would this look like if I said show SD-WAN BFD session, just to see? It's been a long time since we looked at it, see if we have two. No, we don't. So, from this scenario, what we see here is that we only have one connection up and operational. My IPsec reachability isn't working, so I can't form a tunnel between devices. Now, that begs the question. Now, one of the things I've been trying to do is I've been trying to avoid a lengthy conversation about the theory behind how things work. But right now, we can't avoid it. The issue that we need to take into account here is that we need to notify the vSmart about the identity of our T-locks, transport locators. Transport locators are going to end up being the designations that we're going to use to create IPsec tunnels. So I have a T-lock that I'm going to use. In fact, I have two. So I've got my system IP address, the color of the transport, and the encapsulation type, which by default I'm using IPsec. Now, the scenario that we have to understand here is that we need to, first of all, recognize whether or how we're going to be identifying these. So when it comes right down to it in SD-WAN, the centralized component that is going to be responsible for all forms of route exchange. So cEdge1 learning about routes that exist on cEdge11 or vice versa. The device that's responsible for that is the vSmart. Now, the vSmart is going to learn that information and it's going to advertise it, or as I say, a lot of times I tell everyone that the vSmart is kind of like a route reflector. It learns about information in VPNs and then it reflects that information to other devices that have that VPN/VRF. But it's also responsible for learning T-locks. It's also responsible for disseminating information about T-locks. So let's go ahead and take a look at what's happening on our cEdge. So what I'm going to do is I'm going to go ahead and say show SD-WAN, and I'm going to say OMP T-lock paths. And what I want to know is, am I learning about the T-locks on cEdge11? And am I learning about them from the vManage? And what we see here is that the only T-locks that I have in my table are going to end up being the T-lock paths associated with public internet. Now, I know I have two. We've looked at them. In fact, cEdge1 and cEdge11 both have the transport of MPLS. Now, the job of the cEdge is to advertise that fact to the corresponding devices. But right now, this device only is making a registration for or advertising its individual MPLS T-lock. So let's double check it. So I'm going to go ahead and say show SD-WAN running configuration. I want to look at SD-WAN. And let's just make sure that everything is configured the way it needs to be. So SD-WAN, tunnel interface is on. We're using a color of public internet. I should be allowing services all. There it is. Let's take a look at Gigabit Ethernet 2. Now, Gigabit Ethernet 2, tunnel interface is on. We are using a color of MPLS. And we can see here that, again, I'm also allowing service all. So it's identical configuration on the devices, but this device is making no record of the fact that it has its T-lock. So if I say show OMP T-lock, or let's say show OMP or SD-WAN OMP peers, we have a peer to the vSmart, and it's purely through my one transport that supports it. Let's go ahead and take a look at the show SD-WAN OMP T-lock paths, which is going to give me all of the T-locks that I know about. But the issue is that I'm learning about this one right here. I'm on cEdge11. I'm learning about Site 100 cEdge1 from the vSmart. And I'm only notifying the vSmart about my individual connection. Now, what I want to do is I want to see if this is a problem associated with forwarding. So here's what I'm going to do. All right, I am going to connect the MPLS router to the public internet router, and I'm going to run a routing protocol on both. I'm already running OSPF on MPLS. I didn't need it. I was just trying to demonstrate that it's not necessary. In fact, all the way over on the public internet, I don't have any configuration with regard to a routing protocol running. So obviously, that was just an attempt to do some troubleshooting, to take a look at what's happening, and it turned out to be a red herring. Now, the other part of this is going to end up being the fact that I'm only forming one IPsec tunnel, and I only have control plane connectivity to the vSmart through public internet, not MPLS. So let's take a look at what happens if I jury rig an intermediate solution. So here's what I'm going to do. I'm going to grab an interface on MPLS and on the internet. I'm going to go ahead and say we'll use Gigabit Ethernet 9 in both cases. And what I'm going to do is I'm actually going to run a routing process between the two. I need to give it an IP address. Now, how in the world did it do that? Let me refresh the configuration. All right, so I'm going to give this an IP address. So I'm just going to edit its style, and I'm going to write in here 52.52.52.0/30. And what I'm going to do is I'll do .1 on the internet side, and I'll do .2 on the MPLS side. So let's go to MPLS first. And again, this is just ad hoc troubleshooting. I don't intend to leave this in, but I do want to see if it has a direct effect. All right, so let's take a look at the configuration on MPLS. So I'm going to go to interface, big T, interface, Ethernet, Gigabit Ethernet. I'm used to using CRBs. Gigabit Ethernet 9 IP address 52.52.52.2.255.255.255.252. I'm going to say router or IP OSPF 1 area 0. Go ahead and run that in the interface. Let's go ahead and take a look at the internet router. And show IP OSPF interface brief. Let's see. Don't have any OSPF running as I illustrated before. I'm going to go to interface Gigabit 9. I'm going to interface Gigabit Ethernet. Big T interface Gigabit Ethernet 9. I'm going to go ahead and say IP address 52.52.1.255.255.255.252. Exit. We're going to say router OSPF 1 area 0. Router OSPF 1. I'm going to say router ID 00001. I'm going to say network 39.0.0.0.255.255 area 0, and I'm going to run network 52.0.0. I usually do this as exact as possible. I'm just trying to get fast. And interface Gigabit Ethernet 9, no shut. Right. Let's take a look at MPLS. Interface Gigabit 9. Shut. Show IP OSPF brief. All right, so the state is down. I thought I did run 9. There it is. Up now. So 9 is up. Just trying to be quick. Obviously, not good at it. So let's say show IP OSPF interface brief. Now, I don't want to go through here and do all the passive crap and everything, but I am waiting to see if I get a neighbor adjacency between these resources. So I've got 52.52.52.130, and if I do interface brief over here, I've got 52.52.530, and there's my neighbor. I could have done point to point and all of that garbage. I just decided not to mess with it. Now, here's the situation. So as a direct result of what I just did, let's see if there's a change that takes place on cEdge 11 and cEdge 1. All All right. So let's take a look at, say, for instance, the show IP interface brief. We'll do e-assigned just to streamline it a little bit. And we've got our addressing in place, show IP route. All right, so we've still got our static default routes in play. Let's take a look at show SD-WAN, OMP, TLOC-paths, and see what we see as far as our TLOC paths. Now look what just happened. So by virtue, all I did was extend this interface from here to here via the Gigabit Ethernet 9 interface, but now I actually have two tunnels. So let me rephrase that. I'm learning the TLOCs. So notice here, I'm learning about this is 11, I'm originating it. And this guy right here is going to end up being this is the MPLS connection that I'm originating. This is the MPLS connection that I'm learning from the vSmart. And the issue here is that now if I do show SD-WAN, I say BFD sessions, what we're going to see is that I should have, now I've got a bunch of tunnels, not just 4 tunnels. In fact, what's happening here is I'm actually cross-resolving. So notice I've got public internet can communicate to public internet. Public internet can communicate to MPLS. MPLS can communicate to public internet. MPLS can communicate to MPLS. But the problem is that this is not what I wanted to have configured in the environment. I don't want MPLS connected. So this begs the question, why did it suddenly change? Well, here's the issue. Since the MPLS connection does not have the capability of being able to communicate via the MPLS transport to the vSmart across that transport, it is not looking like it is a tunnel that's available to use. Let's go ahead and disable that connection. So what I'm going to do right now is I'm going to go up to 9. I don't want it. I'm going to go ahead and just suspend the link using a feature inside of Eve. That link, that peering should go down. And as a result of that peering going down, the cross connection between MPLS and internet should suddenly stop working. All right, so let's look at it. So let's see, do I still have my tunnels? So show BFD sessions. And what we're going to see here is those tunnels are now down. Now, as a result of those tunnels being down, it's because this connection is not live. So here's the deal. So what's happening is from cEdge 11 and cEdge 1's perspective, this path through MPLS is not appearing as a candidate to be used because the problem is that it needs to report its existence directly to the internet, or excuse me, to the controller through internet to make internet active. MPLS is not being reported as being quote unquote active as a direct result of the fact that this link between internet and MPLS is down. Now, this is one of the reasons that in most labs, you're always going to see these devices connected. However, in the real world, if this is a public transport, which public internet doesn't get much more public, and MPLS is a private transport, the scenario that we're illustrating here by not having that link between internet and MPLS is reflective of a real-world situation. Now, what I want to do is I want to make one modification. I want to make one change to the environment to see if I can't remedy this issue. And what we're going to see here is again, these connections are, ultimately showing up as being down. So from the perspective of this, the connection that I have here, all of these cross connections are quote unquote down. But what's happening here is that MPLS is now still an effective link. So let's go ahead and say, take a look at SD-WAN, OMP, TLOC paths. And we can see that we still have all of these inferences in our table. So what I want to do, first of all, is both on cEdge 1 and on cEdge 11, I'm going to type clear SD-WAN, OMP, connections. So I'm sorry, control connections. And wipe those connections out. Again, I'll do the exact same thing over here. This is basically just clearing out all of my OMP exchange. I'm going to say clear SD-WAN, control connections. And let's see what happens. So I'm going to go back to cEdge 11. And from cEdge 11's perspective, we can see here that we have disconnected from the vManage. We've reconnected. So we cleared all of those connections. And let's go ahead and say show SD-WAN, OMP, TLOC-paths, and see what we're learning. Now, in this scenario, I'm not learning about MPLS. Even though I have MPLS locally, if I go to cEdge 1 and I say show SD-WAN, BFD sessions, we're going to see I only have the one tunnel. And if I say show SD-WAN and I want to look at OMP TLOC paths, I'm not learning anything about MPLS. Now, one other validation would be to go to the controller, and I want to see what the controller's learning. So if I log in admin 1234 QWR, and I'm going to go ahead and say show OMP TLOC paths, what I'm seeing here is the controller is only learning about public internet. Now, I don't want anybody to get distracted by this link. It is down. Notice it's got the two little red dots in it. Now, ultimately, when I resolve this, I want to make that go away. So here's the dilemma. What we have by default in the configuration is the fact that right now, cEdge 11 and cEdge 1, both based on the configuration of their feature templates, are trying to form a control plane connection with the vManage, the validator, and the controller across MPLS, but MPLS does not have the capability of being able to allow that connection to take place. So as such, what's happening is since I can't communicate to the vSmart, validator, and vManage through this MPLS connection, it's not candidate to be used for a tunnel because it can't bring that control plane into effect. So what we want to do now is we want to take a careful look at some possible modifications that we can make. So if I can't form a control plane connection across MPLS, why should I even try to form a control plane connection across MPLS? So from the perspective of, let's pick a device, cEdge 11. I'm going to go ahead and say show SD-WAN, running configuration. And again, let's look at SD-WAN. You can't do tab complete, Terry. And I know this is like the 10th time that we've looked at this, but what we're going to look at here is that we need to understand that there are some values in here that we may want to pay attention to. And again, some of these configurations are going to end up being default. So notice we don't really have any options in here with regard to control plane connections. But let's take a look at it from the perspective of the feature templates. So I'm going to go to configuration, go down to classic. We're going to go to templates. We'll navigate to feature templates. And what I want to do is I want to look at the Gigabit 2 interface template. I want to edit it. Now, bear in mind, it's attached to a device template that has two devices attached to it. So if I make them a change and I update it, it's going to force that change to quote unquote be propagated. So let's look at some of our options here. So right now we see that I have the hardwired interface. No big deal there. It's no shut. We have the IP address. That's working for me perfectly fine. What I want to do is I want to scroll down to tunnel, and under tunnel, you'll notice here we've got maximum control connections. Now the maximum control connections is set to default values if I leave this default option. But what I want to do is I want to globally set this to 0, zippo, none. I don't want to form control connections across the MPLS interface. So let's go ahead and update that. And like I said, vSmart's intelligent enough to realize, hey, where's devices attached? Let's go ahead and propagate Terry's intent. So I'm going to go ahead and say configure devices, and we're going to confirm. And let's see what happens. Now, first of all, we should see a change in the show run output for SD-WAN, specifically SD-WAN. But let's just take this one step at a time. We'll wait for this to apply. Devices pulled config. Configuration has been applied successfully. Real quick, let's go ahead and bring back the topology, and let's take a look at the running config. So I'm going to repeat my show command here on 11. And what I want to do is I want to look at the configuration here for Gigabit Ethernet 2. So 1 has no change. Let's see what we see for 1. Notice it says max control connections. That command is not visible under Gigabit Ethernet 2 because it's set for default, which should be at minimum 2. So the maximum control connections that I have right now is set to 0. Now, by virtue of the fact that I'm now no longer going to attempt to communicate to the vManage, vSmart, and vBond via Gigabit Ethernet 2, let's see if that made a change. So all I'm going to do is I'm going to go ahead and say show SD-WAN OMP TLOC-paths. And let's see if I'm learning MPLS. Et voila, I'm now learning MPLS. So here's the caveat to this. All right, so MPLS right now, even though I've physically connected it, I've actually disabled that link. I'm going to delete it because I don't want there to be any confusion as to what's happening. But by virtue of the fact that I have now said, all right, TLOC MPLS, you don't need to try to form a peering relationship to the vSmart, because by having that capability enabled by default and not allowing it to happen by not having some type of cross connectivity, what I've actually done is I said, well, if you can't communicate directly to the vManage is never going to learn about the availability of the TLOC through MPLS on either CE1 or CE11 or any other device in my lab that will be connected to MPLS in the future. So by failing that, what it's basically saying is something's wrong with the connection, so don't report that as an active TLOC. However, by changing the max connections to 0 on MPLS, now I'm no longer trying to connect. So the assumption is that if I can't form a peering relationship through MPLS, the TLOC needs to be reported through public internet. So without having to have the cross connectivity in place and without having to do any other significant modifications, all I do to remedy my problem is to change the max control plane connections from the default to 0, thus making certain that MPLS, quote unquote, is not detected as being a failed data path that can reach the controllers. So with that, let's go ahead and remove that link entirely. So I'm going to go ahead and right click, and I'm going to go ahead and say, I want to delete this link. The link should go away. Now what I want to do is I'm going to go back to my cEdge, and from my cEdge, I'm going to say show SD-WAN OMP peers, and we should now have 2 tunnels. I'm sorry, we should have show SD-WAN BFD. We only have one vSmart, so we can only have connection to one vSmart. But I'll say show SD-WAN BFD sessions, and if all goes well, we should have 2 tunnels that are up and operational. And what's happening now is that the system is saying, hey, I can't form that tunnel that was the cross connection. And what I'm going to want to do is I'm going to want to eliminate that as a possibility. So that's going to be the last thing that I'm going to end up looking at here before I stop this video. So what I want to do is I want to prevent the system from trying to form connections between TLOCs that don't match. So let's take a look at cEdge 1 and see if it's doing the exact same thing. So I'll say show SD-WAN, BFD sessions. And what we're going to see here is that from the output here, we have the exact same possibility. So here we see we have 2 tunnels that are down. Now, they're not down because the transports can't communicate to each other. So obviously, data hitting the public router cannot be sent to the MPLS router based on my configuration. Now, I think this looks sloppy, and I think this makes it look awkward. So what I'm going to do is I'm going to make another modification, and that modification is going to end up being done. I'll go ahead and do it to the MPLS config, and this is going to be something called color restrict. So the rule of if I use the color restrict keyword when I assign a color, I'm also going to tell the vManage that I only want to form an IPsec tunnel between colors that match. Now, if I have 2 transports like what we have in our lab, and I make the change on MPLS, that means MPLS is not going to try to form a peering relationship to public internet, thus making these resolved transports disappear out of my list. It's also going to have a converse effect, meaning that since MPLS is not going to try to form a peering relationship with any other color than MPLS, it's also going to end up being a guarantee that if MPLS tries to form a tunnel to, if public internet tries to form a tunnel to MPLS, MPLS is going to refuse it. So as long as I have 2 transports, and only 2 transports, I can just make that change on 1 transport. Now, if I was doing this in a production environment and I wanted to rule this out as a possibility, and I had like a bunch of private transports, obviously, that's something that I would end up doing everywhere. But again, it's going to be based on your desired outcome and your configurational intent. So let's make one more modification to our environment, and then what will be done with this particular walkthrough. So what I'm going to do now is I'm going to go to configuration. We're going to go down to templates. We're going to navigate to feature templates, and I'm going to find MPLS one more time. So it's going to end up being Gigabit Ethernet 2. I'm going to edit it. I'm going to go to the tunnel config. Go to tunnel. And from tunnel, I'm going to turn on globally restrict, which should block the formation of the attempt to bring up those other IPsec tunnels. I don't even want them to show in the overall list as an option. And again, since this is an attached feature template, the device template that has the devices attached to it are going to promulgate a update. So I'm going to go ahead and say next. We'll just go ahead and configure the devices, and we will see if we can't wrap this up. All right, so it has currently been applied. So let's just jump into the console and validate what just happened. So on cEdges1, I'm going to say, show me my BFD sessions. Notice I now only have 2 tunnels. I have public internet communicating to public internet, and I have MPLS communicating to MPLS. And based on my configuration and based on my architecture, everything is working the way that I want it to work. Now, I want to do one other thing, and that is I want to get rid of OSPF on these devices because it's not necessary. I don't want to leave anybody with the impression that it is. It was just a way of being able to demonstrate that the second that I can communicate via MPLS to my controllers, that transport becomes an available TLOC for the purposes of terminating GRE or IPsec tunnels. And simply by turning off the requirement, by taking my max connections to 0, I've now eliminated that transportability check. And then what ends up happening is that the TLOC is going to actually be advertised to the vSmart through my functional control plane connection. So in this instance, I now only have the capacity of having 1 total, and it's working. So with that, things are being communicated directly. So what I want to do right now is I'm going to go to MPLS. I'm going to say config config T, no router OSPF 1, end right. I'll go to internet and do the exact same thing. En big T. I will say no router OSPF 1. So IP OSPF interface brief, nothing. So at this particular juncture, everything should be good to go in my environment. So just one more time, let's just take a look at the secure CRT on cEdge 11. Let's make certain that we still have the 2 tunnels. If I say show SD-WAN control connections, what we're going to see here is that I have a connection to the vSmart, a connection to the vBond, a connection to the vManage. This is the this connection to the vBond has come up and gone down because they're temporary. But for all intents and purposes, my lab is working exactly the way that I want my lab to run. Now, again, we got more than we bargained for in this configuration by simply creating an environment where I'm using a public and a private transport methodology where the public and the private can't communicate to each other. And as a direct result of that, we had to deal with some of the resulting fallout out of that design. This is one of the beautiful things about taking recommendations for students with regard to implementation tasks and trying to apply it into a video format. So this is something that I would not have ordinarily thought of to implement in a official curriculum, because again, it's going to end up requiring us to have an understanding of what SD-WAN does by default, as well as what we can make SD-WAN do through the application of configurational intent in the form of templates and configuration groups, or through the utilization of policies and policy groups. So there are a lot of options available to us. I want to make certain that we look at these step by step. And again, I can't wait to hear from you guys with regard to whatever your suggestions are going to end up being for suggested or possible tasks. But until those videos and that information comes in, I'm going to go ahead and wrap this video up. I feel really good about what we've accomplished. I hope you guys got something out of it. And I also hope to see everyone in another video. Till then, take care and enjoy your holidays.